This AI model just changed the game. A new AI model has emerged that might rival OpenAI. A team of researchers from China released DeepSeek R1. While TikTok was down for 12 hours, AI researchers were making history. DeepSeek R1 is performing exceptionally well on reasoning-heavy tasks like math, coding, and scientific problems. It's scoring at the level of OpenAI's GPT 4.0 model. The research highlights three key takeaways: how chain of thought improves AI reasoning, how pure reinforcement learning allows the model to train itself, and how model distillation is making powerful AI more accessible. Chain of thought is a powerful technique where AI is prompted to explain its reasoning step by step. This method enhances transparency and allows researchers to pinpoint errors more effectively. When solving a math problem, DeepSeek R1 doesn't just give an answer. It walks through the logic. The model even self-corrects when it recognizes an inconsistency in its own reasoning. This enhances accuracy and reliability. Reducing hallucinations is a crucial goal in AI development. Chain of thought reasoning enables AI models to verify their responses, reducing errors in critical fields such as law, healthcare, and finance. DeepSeek R1 uses reinforcement learning differently from traditional AI models. Instead of feeding it labeled data, the model explores different problem-solving methods and learns from its own experiences. Unlike models that rely on memorization, DeepSeek R1 refines its approach over time, much like a child learning to walk. It adapts by optimizing its behavior through trial and error. Traditional AI training requires extensive human-generated labels, which is costly and time-consuming. DeepSeek R1 minimizes this dependency by allowing the model to improve on its own. DeepSeek R1 ultimately surpasses OpenAI's GPT-4.0 Turbo in performance. With continued training, it could achieve even higher levels of accuracy. DeepSeek R1 consists of 671 billion parameters, making it an enormous model. Running it requires thousands of GPUs. To make it accessible, researchers use model distillation. Model distillation allows a large AI model to train a smaller one. The smaller model mimics the larger model's reasoning, making high-performance AI more accessible. DeepSeek R1 has been distilled into Llama 3 and Qwen, smaller models that still perform at a high level while being far less resource-intensive. These distilled models outperform some larger models, including GPT 4.0 and Claude 3.5 Sonnet, in tasks like math and coding. This proves that smaller, well-trained models can still be highly effective. DeepSeek R1 improves its accuracy by analyzing past performance and adjusting its approach. Unlike other AI models that require human intervention for refinement, this one guides itself through reinforcement learning. Future AI systems could become even more autonomous. Instead of simply responding to prompts, AI models may set their own goals, analyze data, and improve with minimal human oversight. A significant challenge in AI development is cost-effectiveness. Training large AI models demands enormous computational resources. DeepSeek R1 self-improvement capabilities reduce the need for continuous human training and data collection. Balancing power and efficiency is a challenge for AI companies. DeepSeek R1 presents a potential solution by creating more sustainable AI training methods without reducing performance. Healthcare could benefit from AI models like DeepSeek R1. Self-correcting AI could lead to improved diagnostics and earlier detection of diseases. The financial industry could also see improvements. AI-powered risk assessments could become more accurate by continuously refining analytical methods. Scientific research may be revolutionized by AI models that self-optimize. AI can refine research methods, accelerate breakthroughs, and improve the accuracy of experiments. DeepSeek R1's reinforcement learning approach is also essential in robotics. Adaptive learning allows robots to improve movement and decision-making based on experience. Tesla's self-driving technology relies on reinforcement learning. DeepSeek R1 extends this method beyond navigation, applying it to problem-solving across various domains. Reinforcement learning stability is a key challenge. AI models that change too rapidly can become erratic. DeepSeek R1 incorporates policy optimization to ensure gradual, stable improvements. Stability is crucial for real-world AI applications. If financial models or AI assistants altered their behavior unpredictably, it could lead to widespread issues. DeepSeek R1's structured learning prevents such instability. DeepSeek R1 generates high-quality training data using chain-of-thought reasoning. Structured reasoning improves the reliability of AI-generated content and training material. AI bias is a major concern. Poor quality data can lead to biased outputs. DeepSeek R1 reduces this risk by structuring its reasoning process and improving response consistency. Accessibility is another benefit of DeepSeek R1. High-end AI models typically require powerful hardware, but model distillation enables more people to access advanced AI capabilities. Expanding AI accessibility fosters innovation. When more developers and researchers can experiment with AI, it leads to new breakthroughs and applications in various industries. AI is evolving rapidly, and DeepSeek R1 represents the cutting edge. By combining reasoning, reinforcement learning, and distillation, it sets new standards for AI research. Autonomous AI is on the horizon. DeepSeek R1's research marks a shift toward more intelligent, adaptable AI systems with far-reaching implications. DeepSeek R1's real-world applications extend beyond industry use cases. Education is another field that could benefit immensely from AI models capable of structured learning and reasoning. AI-powered tutors could provide students with step-by-step explanations, helping them grasp complex concepts in mathematics and science more effectively. Natural language processing advancements powered by DeepSeek R1 could also enhance real-time translation services, making cross-cultural communication smoother and more accurate. Cybersecurity could also be improved with AI models like DeepSeek R1. Threat detection systems could become more intelligent, identifying vulnerabilities and preventing cyber attacks before they occur. Legal research could benefit significantly from AI that understands context and logic. DeepSeek R1 could assist lawyers by analyzing case law and suggesting relevant precedents, streamlining legal research. AI-generated content could be enhanced by incorporating DeepSeek R1's reasoning abilities. Articles, reports, and summaries could be more accurate and insightful, reducing misinformation. Smart assistants could become significantly more useful. Instead of just responding with pre-programmed answers, AI assistants could think critically and provide more in-depth responses to user queries. DeepSeek R1's development signifies an AI shift toward greater autonomy and adaptability. Future AI systems may no longer need constant human oversight, but instead continuously refine themselves. AI ethics and regulations will become increasingly important as AI gains more autonomy. Ensuring AI models remain unbiased, ethical, and aligned with human values will be crucial. DeepSeek R1's self-learning capabilities could transform industries in ways we have yet to fully realize. The potential applications are vast, spanning automation, creative industries, and problem-solving domains. The long-term impact of DeepSeek R1's technology could set the foundation for AI that not only assists humans, but also collaborates with them in solving complex global challenges. How do you see self-learning AI shaping the future? Let me know in the comments.